Okay, guys, we're starting a new section. This has to do with action potentials, and this is the really hard part of this chapter. So I'm going to go slow. We're going to get through this. Okay, before we understand action potentials and how an impulse is actually sent in a neuron and how they communicate, we have to realize that this communication deals with two things: a resting membrane potential and presence of specific ions. Remember, we've already talked about some ions that can be involved: calcium and sodium. Y'all mentioned the other day potassium too. These are important ions in a electron action potential or neuron action potential, sorry. Okay. So you also have to understand what a cell looks like within it within the neuron itself. The neuron has the potential to see a difference in electrical charge on the inside and outside. This is called membrane potential, and we see it in many cells. We saw this membrane potential also in a muscle cell whenever we start that the sodium to go in so the calcium can be released from the troponin. Okay. Also, a cell with a membrane potential is called polarized. It has the ability to change potential or go from positive to negative or negative to positive. So we have a cell that has the possibility of being positive or negative and can change, being a polarized cell and having that membrane potential. But a cell that is not actively sending an impulse is said to be at resting membrane potential. The voltage in the cell is at rest. And this is a, not an unusual thing, but we have a lot of sodium on the outside and a lot of potassium on the inside. And we have a lot of positives on the outside of the cell and not as many positives on the inside. We're going to come back to that look and to that cell in just a little bit. Sorry, I'm having a hard time with this. We're going to get through it though. Okay. Ion channels. It's important to understand that how these ions move is through certain channels that we talked about in chapter 2. Or was it 3? I think it was actually chapter 3. Okay, so the ion channels move sodium and potassium around where it needs to go. And there's several types. So some of them are going to diffuse one way in the membrane and some of them are going to diffuse the other way through the membrane. As they've diffused, they result in the current that flows through the membrane potential. In other words, going from positive to negative. Okay, so there's two types of receptors that are working in this and receiving and setting in these neurons. One is a ligand-gated channel. Now that we saw in the neuromuscular junction, and that's what we're going to see again when they talk neuron to neuron, going from cell to cell. Remember, neurotransmitters bind to that ligand, and then now the ions can enter. The next gate is a mechanically gated channel, the receptors for touch. So the mechanically gated channels is when a sensory neuron is turned on, like touch, pressure opens the channels to the ions. There are two more linkage channels, which allow streams to go back and forth between sodium and potassium in a diffusion rate. So they don't need energy. But what does need energy is voltage gated channels. They open and close on command. And remember, 3 sodiums go out of the cell, 2 potassium into the cell. They respond to change in membrane potential. Now, what I'm going to do in the next lecture is I'm going to tie all of this environment together to show you how we actually send an action potential. This one is just setting the stage for the action potential.